Hello, I'm Didier Stevens, analyst with Enviso. Last May, ESET announced that they had found a malicious PDF in VirusTotal on VirusTotal, and it contained 2 0 days. There was 1 0 day for Adobe Reader for remote code execution, and another 0 day in Windows for privilege escalation to break out of the sandbox. So back then I analyzed that PDF, and we immediately sent out an early advisory to our customers. So the Windows escalation privilege is inside a Windows executable hidden in the PDF, and here in this video I'm going to show you how you can use static analysis tools to extract that Windows executable. So I have the two samples here, the malicious PDFs. So this is the sample with only one exploit, the PDF exploit, and this one here has two exploits, the PDF exploit and the Windows privilege escalation exploit. So with PDF ID, let's start looking at that first one. So I mean the one with only one exploit. And as you can see, it contains JavaScript and also an open action. Now that is typical of malicious documents, that they contain JavaScript and something to trigger the JavaScript upon opening, like an open action. So with PDF parser, let's search for the JavaScript. So I search for JavaScript. And so it is object 11 that contains the name JavaScript, and the JavaScript itself is in object 1. So let me take object 1. And this object contains a stream that is compressed, flat decode. And it's 26,000 MB, so it's rather large. So let's decompress this, and we do this by applying the filters. So F, apply the filters. And here indeed, we see JavaScript, and here a lot of hex code. Also here a lot of escaped white space, like tabs, carriage return, new line. So it's probably that this proof of concept sample has quite readable JavaScript. So let's try this. And we are going to use option raw and W raw to see the raw output without the escaped white space, for example. And then indeed here you can see you have quite readable JavaScript. And here a very long sequence of hexadecimal data. It goes on and on. Okay, so here we have the object, and here the compressed variable DLL data is equal to that. Okay, so we need to decode these lines with all that hexadecimal data, and we can do that with Base64 Dump. This kind of encoding, hexadecimal that starts with 0x, that is called ZX encoding in Base64, and you have two variants depending on the ordering of the bytes here. So you have little endian and big endian. Little endian means that the least significant bytes are here, and big endian is that the most significant bytes are here. Now I know from experience here that we are dealing with little endian, but if you don't know, you can just try out the two encodings and see which one gives you the best results. So let's do this. This output, I piped this into my Base64 Dump tool. So that's a tool to recognize all kinds of encodings. I started with Base64, but it supports other encodings too, like the one here that I said, 0x little endian. Okay. And then here indeed we see all those sequences, hexadecimal sequences that are recognized and then decoded and parsed. But that is each time an individual, while what we want is the complete sequence. Now remember that if we go back here, let's do a less. Remember here that those are all separated by commas. So we should remove those commas to make a longer sequence. And also here with new lines. So we should also remove those new lines to make one long sequence that Base64 Dump can recognize. So that's what we are going to do. Here with Base64 Dump, encoding ZXLE, now we are going to say ignore the comma, like this. So that character is ignored. And then you can see that we already get longer sequences, like here 190 and here 330. So those are all the hexadecimal sequences, and with 0x before, you can see it here, 0x 8 hexadecimal digits, and then again 0x 4 hexadecimal digits, and so on. So that's the x that the comma that has been eliminated, ignored, and now we are going to do the same for white space, and that's with Option W. And with Option W, you also ignore white space, like this. Okay. And then here you can see one big decoding here, about 100,000 bytes. So that's very, very likely our payload. So let's take a look into this. We can check if this contains a Windows executable, a PE file, and we do that with a Jara rule that I developed, contains PE file. So with Option Y here, I can launch Jara rules on the files here, and indeed, so this decoded sequence here contains a PE file. Now we see that it doesn't start with MZ, so the PE file is not at the beginning, but somewhere later. And with Option Jara strings, you can get the list of all the strings that the Jara rule found, like this, and you can see here the MZ string is found at 4 positions here, those 3 positions, those 3 positions here. So what we want to do is to select out that PE file. So take all the bytes starting from the MZ. So this, it could be this position or this position. We have to look. And we can do that with an option in Base64 Dump. So first we are going to select the first decoding, and because it was the first one, 110,000 bytes, so that's the one that we need to select. And then we are going to cut, Option C, cut. So we are going to cut out the bytes that interest us. And the thing we can do is say 0x and then this address here, and then select the bytes starting from that address. But there's an easier way, and that is to use the following syntax, like this, square bracket, single quotes, MZ. So that means that we want to start our cut, start our selection from the first instance of the string MZ. And then double quote, and then nothing, to indicate that we want everything until the end, like this. I'm going to do an Ascii dump so that we can take a look at the bytes that we have and pipe this into less. Okay, like this. And then indeed you see that it starts with MZ, but if you look further, you don't see any strings, neither PE. So this is most likely not a PE file. So that first MZ was not the right one. So let's try out the second address that was found, and we can do that with option 2. Index 2, say that we want a second instance of MZ that is found. And then indeed here now you can see this program cannot be run in DOS mode, and here PE, and here the section. So this clearly looks like a PE file. So we can now analyze this further with another tool. So instead of an Ascii dump, we do a raw dump, and we dump this, and we pipe this into PE check. And that's a tool to analyze PE files. So, and indeed, PE check has been able to analyze the file. It is a PE file. If we look here, it is a 32-bit. Here and here it's a 32-bit file, and it is a DLL. So that is actually what is going on in the first sample, the one with only the Adobe exploit. It contains a DLL that just displays a message box, and the DLL is loaded directly into memory by shellcode. And the shellcode, that's a sequence of bytes that you can find at the beginning. So if we go back without the cut here, so we select the first stream and do an Ascii dump like this, and pipe this into less. Okay, what you see here, that is the shellcode that is able to load the DLL from the memory directly into the memory of the Adobe process. So it's a fileless operation. So that was for the first sample and the first executable. And if you do the analysis on the second one, you're going to see that it's actually the same. So we can use exactly the same commands. All those commands here that we used on the first PDF, we can just use it also on the second PDF. Like this. Okay, you see indeed a PE file was extracted. It's again a 32-bit, but this time it's an executable, so it's not a DLL. And here the executable contains the privilege escalation, is loaded filelessly into memory and then executed to achieve the privilege escalation and as such break out of the sandbox of Adobe Reader. And one last thing, so we are going to pipe this into strings to see all the strings that are inside that executable, like this. And let's scroll back up. Okay, so you probably saw in Microsoft's blog post the screenshot of the VBS, the Visual Basic script that was embedded, and that's the script that you see here, like here the get statement, and writing this to a file and executing it. And one last interesting bit that I want to show you here is some debug information, the location of a PDB file, and that here, that path eCode 2018, for example, ending with .pdb, that could be a very distinctive IOC. And we used that back then in May on VirusTotal to look for samples, but we only found these samples and no new samples. If you want to learn how to analyze malicious documents like PDFs, Office documents and other documents, we have private and public trainings for that. So the private trainings, you can contact us at info@nviso.be, and for the public trainings, that's often at security conferences. The next one will be at the Brucon conference in Belgium in the beginning of October 2018.